Alright, ladies and gentlemen, today we are going to go over quadratic function in vertex form. Remember that before this topic we were learning quadratic function in standard form. What was the standard form? Y is equal to ax squared plus bx plus c. And we also learned how to find the vertex y-intercept. Today we are going to learn quadratic function in vertex form and how we are going to use the vertex form to be able to graph the function. So, first of all, before explaining everything in detail, I would like to give the difference between the f of x and g of x. I would like to graph this and you are going to see that what is the differences between them. So, to be able to graph any function, the best method is making a table. Inputs f of x and g of x. You can give any x values to be able to find ordered pairs for f of x and g of x. So I would like to start with -3, -2, -1, 0, 1, 2, and 3. If you substitute -3 into the f of x function, you are going to find 9 because -3 squared is 9. What about -2? -2 squared is 4. -1 squared is 1. 0 is 0. 1 is 1. 2 squared is 4. And 3 squared is 9. These are ordered pair for f of x. What about g of x? If we substitute -3 into the function here, -3 squared is 9. 9 minus 4 is 5. If we substitute -2 squared is 4. 4 minus 4 is 0. If we substitute -1, -1 squared is 1. 1 minus 4 is -3. If we substitute 0, it's going to be -4. If we substitute 1, 1 squared is 1 minus 4 is -3. 2 squared is 4. 4 minus 4 is 0. And 3 squared is 9. 9 minus 4 is 5. So these are the ordered pairs for g function. Let me graph these two functions. First, I will graph f of x. What are your inputs? -1, -2, and -3. This is 0. +1, +2, and +3. Now we are going to determine the numbers on the y-axis. Let me increase this 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now let me plot the points belongs to f function. -3 and 9 is your first ordered pair. -3 and 9. Next point is -2, 4. -2 and 4. Next point is -1 and 1. Next 0 and 0, which is turning point. This is the vertex. Next one is 1 and 1. After that 2 and 4. And then 3, 9. If you connect the points, you are going to get f of x function. Let me try to combine the points. So this is your f of x. Now I am going to graph g function. What is the first coordinate? -3 and 5. -3 and 5. Next, -2 and 0. After that, -1 and -3. -1, -2, -3, and -4. So, -1 and -3, -1 and -3. Next, 0 and -4. Next, 1 and -3 again. Next, 2 and 0. 3 and 5. If we connect this point, if you connect these points, you can get g of x function. Here we go. So this is your g of x function. When you compare these two functions, you will get that. For example, compare the vertex. F of x function is your main function, and its vertex is 0, 0. And what happened to vertex? Your vertex is translated 4 units down. And when you look at this point, which is 1 and 1 in the f function, this is translated 4 units down, and this is another point on the f of x, and is also translated 4 units down as well. So we can say that, ladies and gentlemen, g of x is the transformation of f of x function vertically 4 units down. So we can see this easily on the graph. We can write it down. G of x is translated function, translated function of f of x 4 units down. Next slide. So before the next slide, I would like to go over the vertex form one more time. Vertex form is this. Y is equal to a times x minus h squared plus k. From here, h stands for horizontal shift, left or right. K stands for vertical shift, up or down. And if you try to find the vertex, your vertex is h, k. This is the vertex, which means that turning point. And A is going to determine whether your function is upward or downward. If A is positive, your function is upward. If your A is less than 0, your function will be downward. All right, now look at this question and be careful. Whatever your question, whatever your function you have, you will compare with main function f of x is equal to x squared. All right, let me try to write h of x in the vertex form. So according to vertex form, x minus 0 squared plus 3. Can you please tell me what is the h here? H is 0, which means that there is no horizontal shift. What is the k? K is 3, which means that vertical shift 3 units up. So what is your vertex here, ladies and gentlemen? Your vertex will be 0, 3. So what happened? Your original function is going to be translated 3 units up, and then you will get h of x. Let me try to write the g of x in vertex form. G of x is going to be x minus 3 squared plus 0, right? Can you please tell me what is the h is? Positive 3, which means that 3 units horizontally right. And k is, what is that, ladies and gentlemen? K is 0. There is no vertical shift. From here, your vertex is, ladies and gentlemen, 3, 0. Is there any question? Now, let me compare g of x with f of x. F of x is the original function. So, g of x is the translated of the function of f of x. 3 units right. So, this is how we compare your function. All right. Now, I am going to graph this function, and then I'm going to show all the important points, which is vertex and axis of symmetry on the graph, and this is the last question. So remember that if you think about your vertex form, which is y is equal to a times x minus h squared plus k. Tell me what is the h here, ladies and gentlemen? Be careful. Here, your sign is positive, in the origin function is negative. So that's why when you try to determine what h is, you need to get this into consideration. So h is what? Negative 1. What is the k? K is negative 4, which means that h is negative 1 means you need to get your function 1 unit to the left. Horizontal shift to the left. K is equal to negative 4 means you need to get your function 4 units down. So your vertex for h of x, your vertex for h of x will be negative 1 and negative 4. You need to start graphing the function, plotting the vertex first. Negative 1 and negative 4. Negative 1, negative 2, negative 3, negative 4. So this is your vertex. By the way, don't forget that axis of symmetry is always x coordinate of vertex. So x is equal to negative 1 is axis of symmetry. So we know that this line is axis of symmetry. What does that mean, axis of symmetry? Whatever the points you have on the right side is going to be symmetrical across the axis of symmetry. After that, I am going to find one point located on the graph, and then I am going to finalize my graphing. So my suggestion, try to find y-intercept as a point. To be able to find the y-intercept, you need to substitute x is equal to 0 into the function. So y-coordinate is going to be equal to 0 plus 1 squared minus 4. From here, ladies and gentlemen, y-intercept is going to be 1 minus 4, which is equal to negative 3. So what is this coordinate? 0, comma, negative 3. So where is that? 0, comma, negative 3 is here. What is the symmetrical of this point? This point is 1 unit far away from the axis of symmetry. So if we reflect this across the axis of symmetry, this coordinate is going to be reflection of this y-intercept. I need to find another point. Let me substitute x is equal to 1. If x is equal to 1, if we substitute this into the function, y-coordinate is going to be 1 plus 1 squared minus 4. This is going to be 2 squared is 4 minus 4, which is equal to 0. So if x is equal to 1, y-coordinate will be 0. So this is going to be your point. What is the reflection of this point? Which is, this is 2 units far away from the axis of symmetry. In opposite direction will be 2 units far away from axis of symmetry. All right, let me graph one more point, which is x is equal to 2. If x is equal to 2, what is the y-coordinate? Substitute. Y will be equal to 2 plus 1 squared minus 4. 2 plus 1 is 3. 3 squared is 9 minus 4, which is equal to 5. So if x is equal to 2, y is equal to 5. 2, 1, 2, 3, 4, 5. So this is going to be your coordinate. This is 3 units far away. If you want to find the reflection of this point, the reflection will be 3 units far away from axis of symmetry. So these are enough for you to graph your function h of x. So what is this? If you connect your points, you can get h of